Now,
Yeah.
I know another location where we've detected some methane, we've seen some, is Enceladus. And we have a report going on from there as well. This is all part of our methane information. Take it away.
Oh, thanks, Dr. Reitzel. Yeah, we do have something interesting on this. We've talked about methane possibly being important for looking for signs of life in the universe, and we've had a sniff of it in an interesting place. The small moon Enceladus, which orbits Saturn, it's a bright, icy moon. The image you see there is from the Voyager spacecraft in 1981. We knew that the surface wasn't just cratered solid ice because parts of the moon, its surface had been reworked. The craters had been erased. So we knew there were some dynamics inside this object. But the Cassini spacecraft, when it got out and had a look at Enceladus, found some truly remarkable things here. It turns out that this moon is actually venting water vapor into space, becoming water crystals and blowing out from cracks and crevices in the crust of this moon. This demonstrated pretty clearly that there is a water ocean underneath that ice. Now, it's very cold out here. You wouldn't think that you could have water this far from the sun, but the idea is that tidal stresses could cause heating inside this moon from Saturn and also from other moons that pass it. This kneading of the cosmic dough produces friction, and a layer of the ice at the bottom would have melted and created an ocean. There would probably be volcanism as well on the rocky inner core of the moon. Now, that kind of environment under an ocean, volcanism, all the rest of that, if the ingredients were right, well, that would look a lot like what we thought life on Earth might have been developing in the primordial times. Well, they naturally would like to get a look at those plumes because it's a sample of that ocean. This is something that came up from the inside. And can we get at it? Yes, we can. The Cassini spacecraft specifically was directed to fly through some of those plumes and to take samples using its instruments to determine the composition of it. And yes, they found methane. In fact, more analysis recently looking at the original Cassini data has suggested there was more methane than they were originally expecting to be there, more than the geology seemed to suggest. This is the chemical reaction that would be used by a methanogen bacteria on Earth. The critical thing is on the leading edge, you've got carbon dioxide and hydrogen being consumed, and that produces a little bit of water and some methane. Now, the carbon dioxide, that was detected in the plume above Enceladus. The hydrogen was detected in the plume. So was the methane. It looks like the ingredients are there, but what's causing the methane? Is it biological or is it just coming from geology? Well, a new study just published in June by these researchers from the University of Paris, Letters and Science. These guys did a detailed analysis and a mathematical model of what could be going on inside Enceladus, the amount of methane that would be in the water, not just in the plume. They think the composition of the plume is a little bit methane poor compared to what would be in the water. So they use the water numbers they think for that ocean. And the answer is that is actually a very potentially habitable environment. First of all, they did have the startling result that the expected geology, the processes we know going on inside Enceladus should produce methane. It doesn't produce enough. So something else is going on. Now, they also found that what they observed in the plume and what they predict for the ocean would just completely be agreeable with the premise of methanogenic bacteria. If this was the Earth and we were looking at it, scientists would have no trouble saying, oh, well, that's probably methanogenic bacteria. But it's not the Earth. It's not a world like ours at all. It's very different. So the final point that the researchers made is it really depends how likely you think it is that life could have developed on Enceladus. If you think it's likely, then methanogenic life forms would make sense. It'd be a good explanation. But if you don't think that's possible, if it seems really unlikely, there must be something else going on. Maybe Enceladus was born with more methane originally than we predicted it was, or there's some kind of a process inside Enceladus that makes methane that's not something we've thought of yet. Anyway, we don't know the answer yet, but it's an exciting development. And for the moment, this little moon is continuing to tease us with its ghostly veils. And believe me, we're going to keep looking.